You are welcome to Physics Medicine online tutorial class. I am your physics teacher, Mrs. Okuma Ijoma. Today, we want to look at the particulate nature of matter. Then under it, we are going to look at the structures of matter, that is atom as matter. Now, we look at the specific objectives. By the end of this lesson, students, you will be able to define matter, atom, and their molecule. Then, secondly, welcome to Physics Medicine online tutorial class. I am Mrs. Okuma Ijoma. Today, we want to look at the particulate nature of matter. Particulate nature of what? Matter. Then under it, we are going to look at the structure of matter, the evidence of this particle nature of what? Matter. Now let's look at our specific objectives. By the end of this lesson, students, you'll be able to define atom, matter, and molecules. Number 2, you'll be able to state 3 evidences for saying that the atom of matter are in constant motion. Thirdly, you'll be able to give 3 evidences that suggest the existence of atom. And finally, you'll be able to give a brief description of the structure of what? Atom. Now, atom as matter. Now, what do we mean by matter? Whenever we talk about matter, it's not new to us. We talk about anything that has mass and occupy what? Space. And you find out that the entire universe is made up of matter. For example, stone is matter, the table in your classroom is matter, chair in your classroom, the buildings around, the trees, cars, they are all what? Matter. So matter is anything that has mass and occupy what? Space, and is the material substance that made up the physical what? Universe. Now this matter consists of tiny particles which we call what? Atom. Matter consists of what? Tiny particles called what? Atom. And the idea of this atom as matter, we say that matter is made of what? Minute particles called what? Atom. An atom is not new to us. Now, let's explain this matter, which we say it consists of tiny particles called what? Atom. Now, if you consider a piece of yam that is being cut into smaller and smaller bits until eventually you get the smallest piece of the substance of that yam that you can no longer divide it. That smallest piece of that yam that you can no longer divide become the atom of that yam. So what do we mean by atom? Atom is the smallest indivisible particle of matter. The smallest what? Indivisible particle of what? Matter. That is that smallest bit of the yam that you can no longer cut again. That is the atom. Or we can define atom as the smallest particle of an element that can take part in a chemical what? Reaction. The smallest particle of an element that can take part in the chemical what? Reaction. Now, atoms, they are always in what? Motion. These atoms we are talking about, this smallest particle of matter, the indivisible particle of matter, They are always in what? Motion. Now, a scientist called Democritus, he suggested that if any piece of a substance were continuously divided, the result will be an atom, a tiny particle of that substance which cannot be divided again, which I have given an illustration using a piece of yam. So that smallest part of that particle of that matter that you can no longer divide becomes the atom. Now, the idea of an atom was not popular during the time of this scientist called what? Democritus. Now, some great philosophers in his days like Plato and Aristotle, they opposed the atomic idea of what? Matter. Why? Why do they oppose the atomic idea of matter? Let's see the reason why they rejected the atomic idea of what? Matter. Number one is because there is no direct evidence to prove the existence of an atom. Because there is no what? Direct evidence to prove the existence of what? Atom. Then secondly, because we cannot see these atoms. So the atoms we are talking about, we cannot see them. So because of this, they oppose the existence of this atom. Then in the 19th century chemist called John Dalton, he revitalized the atomic theory of matter such that now scientists, they can confidently describe the behavior of what? Matter in terms of what? Atom. So using John Dalton's atomic theory, find out now that scientists can be able to describe the existence of matter in terms of what? Atom. Then in 1827, the great scientist called Robert Brown, he observed the first evidence for the existence of what? Atom, which we are going to see later. He performed an experiment using pollen grain. He dropped pollen grain in moving water, then he used microscope to view the motion of that pollen grain. So we are going to see that later. Now, we want to look at the evidence of particles' nature of what? Matter. What are the evidence, or the evidence is now that matter is made of what? Particle. Remember initially we said that scientists in the 19th century, they opposed the existence of this matter as atom because there is no evidence and because we cannot see these atoms. Now we have some evidences for the existence of matter as atom, or the evidence for the particle nature of what? Matter. Now atoms and molecules we are talking about, they are too small to be observed even with the most powerful microscope. We have many evidences that exist that support the idea of matter consisting of what? Atoms. Now we look at these evidences. We have the direct and the indirect evidence. We're going to start with the indirect what? Evidence for the existence of what? Atom. Indirect what? Evidence. Number one, under the indirect evidence, a piece of chalk, you find out that you can crush it into tiny what? Particles or powder. For instance, when you are writing on the blackboard with your chalk, you find out that the piece of the chalk can fly away. So those pieces of this chalk, they are the particle of that chalk. They are the atom that made up that chalk, because the chalk itself is what? Matter. The second evidence is a cube of sugar consisting of tiny particles. If enough pressure is exerted on a cube of sugar, you find out that it breaks up into smaller what? Particles. Now you can see that today we even have the granulated sugar, the one that is being grinded. you see the smallest part of it. That is the particle of that sugar. That is the atom we are talking about. Remember, these are indirect words, evidence. We cannot really rely on them, but we can use them to explain the existence of atom as what? Matter. Number 3, we have the spreading of oil drop on water. Spreading of oil drop on water forms a thin layer of oil film. We are going to see the experiment when we'll be talking about molecule. So you find out that when you begin to spread, or when you drop oil on water, that oil that you drop on water forms what? A thin of layer of oil film. Now that thin of layer becomes the particle. Now you find out that the spreading of oil drop into an oil film suggests that oil drop consists of tiny what? Particles. The spreading stops when one molecule thick of the oil rests on water what? Surface. So you find out that that drop of oil on water, we say that it forms a thin layer of what? Oil film. And you find out that this thin layer of oil film suggests the particle nature of that oil as what? Atom. Now, number 4, we look at diffusion of gas and liquid what? Molecules. Now we are talking about two things here: diffusion of gas and diffusion of liquid what? Molecule. Now you find out that when you open up a bottle of perfume and you spread it at one corner of the room, before you know it, the odor from that perfume will quickly fill the entire room. And this is as a result of what? Diffusion. So you find out that this perfume odor, they spread because they consist of molecules that spread to the parts of the room by what? Diffusion. So you find out that the molecules of this perfume, they will move from one region, that is the region of high concentration, to region of lower concentration. They will spread about. They will fill the entire room, showing you that these particles, they are in constant what? Motion. These particles, they are in constant what? Motion. Now, you equally find out that if you have a drop of ink and you place it at one end of a liquid, then it will spread quickly to other parts of the liquid by means of what? Diffusion. So when you spread an ink at one end of the liquid, before you know it, the entire liquid will be filled with the ink, meaning that this ink, they have diffused. They are in constant state of what? Motion. So the particles of this ink, they move from one point to the another. So this is telling us that these particles, they are in constant what? Motion. Then we look at number 5, evaporation of liquid. Let's say it, evaporation of what? Liquid. Now you find out that a small quantity of water that is left exposed in a tray will disappear after some time. Now in the sunny period, probably you're going out in the morning and your butter of water, you left it open, the water was filled to the brim. You find out that when you come back in the evening, the water will no longer be filled to the brim. Why? Because the particle of this water that has been exposed to the atmosphere, some of them has what? Disappear by means of what? Evaporation. So we said that the liquid has evaporated, and this evaporation of liquid, you explain it by assuming that it consists of tiny what? Particles that escape from the surface of tiny particles that escape from the surface of the liquid. Now we go to another one, that is number 6, dissolving solid in liquid. Now we're going to use a cube of sugar as an example. Now when a cube of sugar is left undisturbed in water, you find out that it will dissolve and spread to the other parts of water. So that cube of sugar, when you drop it inside a water in a cup, before you know it, if you test the water, you find out that the water will taste sugary. Why? The spreading of sugar molecule, we assume that the particle of this sugar split from cube and they spread to other parts of the water. So the particle of this sugar from the cube spread from one point to the other. That is why the water will become sugary when you taste it. Finally, we are going to look at the last one, mixing of two liquids. Mixing of what? Two liquids to give a combined volume that is less than the original volume added together. Mixing of two liquids to give a combined volume which is less than the original volume added together. Now you find out that if you get a liter of water and you mix it with a liter of alcohol, you find out that the volume combined together is supposed to be what? 2 liters. Because in mathematics 1 plus 1 will give us 2. But in this case, you find out that a volume of liquid or a volume of water, a liter of water mixed with a liter of alcohol, you find out that the volume of the mixture will be less than 2 liters. Now this gives us a good evidence to support the particle nature of water. And what happens? Now from the observation, we explain that we assume that the gaps exist between molecules of a substance. Now when you look at, remember the crystal structures we have talked about. In the diagram of these crystals, we find out that gaps exist between the words, between the molecules or between the crystals. So you find out that when water is mixed with alcohol, what happens? These water molecules, they will go and fill that existing gap between alcohol molecules, so that the combined volume now will be less than the original volume. The combined volume become less than the original volume. So these are the indirect evidence for the existence of what? Atom. Now we're going to look at the direct evidence. Direct what? Evidence. The direct evidence is for the existence of what? Atom. Now we find out that molecules, they are so tiny that it is impossible to see them with our what? Naked eye. Remember when we talked about crystals, we said that these crystals, we cannot see them with our naked eyes. The same thing here, these molecules, we can't see them with our naked eye. These atoms cannot be seen with your naked what? Eye. Now the invention of electron microscope, field ion microscope and X-rays gives us strong direct evidence in support of the existence of what? Atom as matter. So we find out that now we look at the direct evidence. Remember the ones we talked about, they are not direct, they are indirect. Now the concrete evidence, we have 2 of them. Number 1, by the use of X-ray diffraction. We find out that X-ray reveals the arrangement of atoms in crystals. Now you find out that with the use of this X-ray, we observe that these atoms, they are arranged as what? Crystals. They are arranged as what? Crystals. Now a beam of X-ray passing through a crystal onto photograph films reveal that atoms are arranged in regular pattern and that gap exists between them. So you find out that these atoms, they are arranged in crystal form, showing that they have definite pattern of what? Arrangement. They have the So we find out that, as we said in the X-ray diffraction, they reveal to us the arrangement of atoms in crystals, showing that they have definite patterns of what? Pattern of arrangement. Now secondly, we have the micrograph from electron what microscope and field ion microscope. That one reveals that matter consists of atoms. Looking at a crystal through an electron microscope, we find out that atoms can be seen arranged in regular what pattern. So with the use of this X-ray diffraction, with the use of our field ion microscope, we found out that these atoms, they really exist, and we found out that they exist as crystals and that they have definite pattern of what arrangements. Now we're going to look at the simple atomic structure. Let's say it, simple atomic what structure. We want to look at the structure of this atom. Now we are looking at this at our level now, that is at our secondary school level. So in this our secondary school level, we are going to consider atom as simply consisting of two parts that are held together by electric forces. And these two parts of atoms, they are what? Nucleus and what? Electrons. What are the two parts of atoms? They are what? Nucleus and what? Electrons. Now let's look at the structure of this atom. Now look at the nucleus. The nucleus is located at the center of the atom, and this nucleus is the heavy portion or the heavy part of this atom. It is located at the center, as we can see from the diagram. Now this nucleus consists of two parts. What are they? When you look at the nucleus at the center, you can see the two parts inside it. You have the proton, which is the positive part. You can see the proton, the positive part. Then you can see the other one that have no charge. That is your neutron. So the two parts of nucleus are the protons and what? Neutron. Now the protons, they carry positive charge, as you can see from our diagram. They are positively charged, while the neutron, they have no charge. Now the second part is the electron. Now the electrons we are talking about, they are very, very light. They are very, very what? Light. About 1/1840 of the mass of proton. So you can see they are very, very what? Light. And they are negatively charged. When you look at the diagram, you can see the proton. You can see the electron, sorry. They are located at the outermost parts of the atom. And that is why these electrons, they are easily transferable. They are located at the outer part of the atom. And these electrons, we say they are negatively what? Charged. Now the lightness of electrons makes it easy to transfer them when two materials are made to rub against each other. Remember, when we talk about method of producing charges, you have by method of friction, method of contact, and other ones. Now you find out that by method of friction, when you rub two bodies together, electrons will be transferred from one to another. One of the body can gain electron or it can lose an electron. We never say they will gain proton or lose proton. Rather, we say that one of the body or the atom gains electron, while the other one may lose what? Electron. Why? Because these electrons, they are at the outermost part of the atom, and they are what? Easily transferable. For example, if you have a neutral atom, you have a neutral atom when the number of protons and electrons are equal. In an atom, if the proton is 16 and electron is 16, that atom has no charge. It is neutral atom. But in a situation when the electron is 16 and the proton probably is 14, you find out that that atom is negatively charged. Why? Because the number of electron is higher than the number of what? Proton. But in a situation where the electron is 16 and probably the proton is 18, that atom is positively charged. Why? Because the number of proton is higher than the number of what? Electron. So we say that the lightness of electron makes it easy to transfer them when two materials are meant to rub against each other. Now the electrons, they circle in orbit around the heavy nucleus, and they are held in place due to electrostatic attraction between them and the protons of the nucleus, as we saw in the diagram. Now in a neutral atom, as I've said, we find out that the total charges due to the electrons must be balanced, or must balance the total charges due to what? Proton. So we have explained it. For you to have a neutral atom, that the number of electron must balance the number of what? Proton. The atoms become what? Neutral. Now we find out that in our today's class we have seen what atoms are and what matter are. We have seen that these atoms are the indivisible particle of matter, and we have seen some evidences that shows us about the particle nature of matter, or that shows us that matter consists of what? Atom. We saw both the direct and the indirect evidence. From the evidence we equally saw that these particles, they are always in constant state of what? Motion. Now we equally saw the simple structure of a atom, where we said the atom consists of two parts. What are they? We say we have the nucleus and the what? Electrons. We have explained all that. Now you will do the assignment. Number 1, give 2 direct evidences for the existence of what? Atom. Number 2, state 3 evidences for saying that the atoms of matter, they are in constant what? Motion. Then thirdly, give a brief description of the structure of atom. Now in this number 3, you're going to draw the structure of atom, then you're going to explain it briefly. Now we have come to the end of our today's lesson. Thank you once again. I remain your physics teacher, Mrs. Okuma.